G'day Bifrosters, we're back on scattering, and this time we're going to be scattering around a strand, which is what this is doing here. There's a strand buried deep inside there, and around that strand is scattered some points. So we're scattering around strands today, and I'm going to show you how to do something like this. We're back on the slightly more complex nodes, a little bit more higher level scattering stuff. We'll scatter around a strand in just a minute. I'm going to take you through how it works, and then I'll show you how to put something like this together so you can make good looking things yourself. Alright, let's get straight into it. So here we go. This is what it looks like when it's not doing fancy things with particles. We have a strand in there. I can show you it. So obviously this is the first thing you need. Now this is just a dummy strand that I'm generating with a noise. I've left the ability to set a size profile on the strand because that comes through to the scatter quite nicely. We'll leave that there for now. I mean, I could bump this up to 2, so it was a bit thicker at the end. Switch this one back on. You can see it's reasonably following the strand profile. Certainly what the strand size profile is really controlling is the size of the points along here more than anything else. If I go back to the profile, I'll take this back to 1. You can see the points there. And you might have noticed that we're hovering just above 0, and that's just to stop these points disappearing into the tail. But you can see that they get smaller there and they're bigger there. So that's a good thing to remember when you're designing strands to put into here. It will take any old strand and all the controls will still be available. I'll demonstrate that in a minute. Okay, scatter around strand, here we go. Unlike the scatter on points or scatter on point, this is using the scatter pack scatter. So we have all of the controls here that come with it for free. Hopefully we've all been scattering points on things for a little while now, and so these won't be too unfamiliar to you. But I'm going to quickly run you through them because there are some here that are just for this node. Scatter around strand. So let's close everything up. Now remember that I'm not showing you how to build these guys. You are welcome to jump in there, read all the notes, leave me comments on how badly I've named things, or whatever you want to do. But this is not a video about building this. This is a video about using it. So we'll sort of take it from there. It's like the scatter on points ones. Scatter around strand. Now this is using the idea that a strand has a beginning and a strand has an end. In fact, the scatter inside of here relies on it having point size and a point ratio on the strand. But it's okay if you don't, because I've put in some property checks here that just checks to see if those two properties, ratio and size, are present, and if they're not, it just creates them for you. So don't be too worried about that. But just in terms of how it works, it takes the beginning, so ratio point number 0, and the end, ratio point number 1, and it does stuff with them. The main thing is it's scattering points around them, and it's doing it in a very, very similar way to the scatter on points and scatter on point, in that it is scattering the points along the strand that you provide, and then generating a spherical point, or a point in a sphere, with that point as its offset. So it's generating a point for every point that you make here. So at the moment it's generating 3030 points, and it's placing it in a random spherical radius around the point on the strand. If you dig in there, you'll see how that works. Basically, all you need to know is that what these control aren't the scatter, they're the spherical random around the strand. So first off, we have a long strand profile, and this is controlling things along the strand, right? So from the 0 to the 1. So I can give you an example. If I just start pulling this up, you can see it's just getting real skinny all the way along. Same at this end. You can see this controls the whole scale. But this is along the strand, so I could do things like reverse it, so it's fed at the other end, or just take it back to what it was and just change the way that it's distributed along the strand itself. So we can get different shapes. We'll go back to what we had. So this controls how things are behaving along the strand. This is the beginning of the strand at 0. There, if I can see that's So anything I do down this end is affecting the points from here. this is 1. I'm going to bring that along, scale it down, whatever. So anything I do here, instead of it being 1 the number, it's 1 as in 100% of the strand. It's this controlling this end here. The next one is a round strand, and this is more about how things behave around the strand. So this one is a lot more similar to the point profile in points in a sphere, scatter points rather. So in that this is controlling, it's still doing the 0 to 1 thing, but it's controlling how things behave around the strand rather than along it. So that's pretty easy. We've already played with that one. After that, we've got scatter mode, amount mode. This is all from the scattering node, so I'm going to assume that you know a bit about that. If not, there is a video at the beginning of this series that explains most of it. This is the minimum radius. You can see that working there, and the maximum radius also works along in conjunction with this. If you set them both to the same thing, you pretty much get a straight line. And this will allow you to lift them away from the strand. It's like an offset. That's cool. You've got the ubiquitous seed, which changes how things are drawn. You get the idea. It's reasonably fast and reasonably responsive. Thank you, Jonah, for helping me with that. So you can add lots and lots of points. And it has the same kind of thing as the, if I drop a noise field down here, it has the same sort of culling setup as the point scatter as well. So maybe, I might want to increase or decrease their frequency or whatever. You can see it's using the density weights as it normally does, whereby saying I have a between 0 and 1 chance, or between 0 and 100% chance of a point going down here. It reads the field at that point, and it decides that there was enough there to scatter a point in that position. So that should be pretty familiar as well. Carrying on down, just going through the culling, just the same as scatter properties. Now this is where things start to get important, and you'll see, well, this is quite important. You'll see where this is going in just a minute. I'll take you through this in a bit more depth when we build our fancy particle snakes thing. But this will take properties from the strand. This is why I needed point ratio and point size on there. So these will transfer these attributes from the strand. Now if we have a look at the strand's watch point here, having a think, you can see that it's got all of this cool stuff coming in. It's got the binormal, the normal position, point ratio, point size, strand index, tangent, strand offset. So this allows me to make a list of which of those I want to pass on to my points. And I'll show you that in a bit more detail in just a second. Set emit location, that's also from scatter, and it's good when we're going to take it to particles. Generate normal belongs to this node. And what this does is it allows you to use the normal of, when this is off, it'll use the point normal coming from the strand itself. When this is on, it generates a normal, which is basically pointing away from the strand. And that's going to be pretty useful in just a second. Normal mode, orientations from geometry, tangent mode, and prioritize normal. That's exactly the same as it is in the scatter pack. So the only difference is that it's going to work out a normal from the strand, but only when this is off. When that's on, it's generating a different normal. There's a reason for that. And then we've got center color in each color, as we have been doing in these custom scattering nodes. Let's get on to, the best way to demonstrate this is to show you how to do something with it. And we can explain as we go. So I'll hide that, and I'm just going to clean this up a little bit, and we'll pretty much just go from there. Okay, so we've got that tidied up. We've got ourselves a bit of screen real estate. Let's start by, let's just make these white. And let's have a little bit less of them while we're working things out. So let's go to 300. And I'm going to just really quickly change my along strand profile a wee bit, which which will become, y will become apparent later, but all I'm going to do is drag that back to 0.8, put in a new one that's at 1, and give it a value of 0. So it basically just, oh, you're annoying. There we go. So basically what I want it to do is just come to a point at both ends, which is fine. I'm happy for these to stay larger than these ones. I'd have to go back and change the strand inputs coming in. It's not going to matter too much as we go. But that's just the first thing I'm going to do. Now let's have a look at these, at some of these normals. So I'm going to need a point scope, and then I'll turn that off. Pop that out to the output for just for now. I'll have a little think, and there it is. So right now what it's doing is, make it bigger so we can see. There's obviously some normals on there because it's using the normals as color. Now let's not use the normals as color. Let's just turn them back to white. But what I'm going to do is I'm going to enable arrows on this point scope, and I'm going to turn this into point normal. And let's make those a bit bigger so we can see what's going on. So you can kind of see what's happening here. There's maybe a bit too many points. Let's go to 30 while we're doing this. You can see that these normals are all pretty much pointing away from the strand. There's the strand, there's the points, and the normals are pointing away, which is great. That's exactly what I want. But just to show you, if I turn off generate normal, they're now just taking the normals of the strand. So whichever way the strand is pointing, the normals that were generated on the strand are being used. I would rather generate my own normals, so let's do that. And I'm doing that because I know that how these are generated, and it's basically just pointing away from the strand. Okay. Something else we're going to do that'll become important later. I'm just going to copy this and paste it down. And I'm going to change this one to green just for differences and make it slightly smaller. We're still just looking at things at the moment. And let's feed that out to the output as well. But what I'm going to do is I'm going to change the arrow property now to point tangent. And so what we've got here are the tangents generated by the point orientation setup inside here. And what's really nice about these tangents is they point along the strand, more or less. If I jump in here real quick and just change the seed, you can see that these are pointing, if not along the strand exactly, then fairly closely at the point that it has been copied. If you have a look here, you'll see that I'm copying point tangent, which means that when a point is scattered, it finds the point on the curve that it's being scattered from and grabs the tangent from it, which in this case, these guys are obviously back here somewhere. This one's somewhere around here. It's kind of harder to see in 3D, but you can usually line up the green arrows with the strand at some point, and they'll match quite nicely. So I'm going to be using those later on as well, in our particles. Well, not even later on, I'm going to be using them now. I'll just leave them on for the moment so you can see what's going on. So basically, yeah, what are we going to do with this? We're just scattering points around a line, more or less. I mean, if the dummy strand was a straight line, we've just got random points around a straight line. You know, it gets kind of skinnier towards one end. It's a bit of a cone, but you know, it's like, what could we use this for? Well, from my own experience, I would be doing things like, well, I can generate a crack using a strand, and then use these as shadow points around that crack, or stitches, random stitches along a wound. There's a million things that I can't think of, honestly, that you can do with scattering around a strand. You could use them to make a flow, which is kind of what we're doing now without getting too deep in the weeds. I should really just get on and do it so we can see what's going on. So let's get fancy. Let's throw down a basic particles graph, just like that. We'll explode it. There it is. There's your basic particles. Now, I don't want any collision today, so I'm going to turn that off. I'm just going to go straight out from scatter around strand into my source particles. All good, all good. Let's get rid of these guys because I don't want to see them just now. And we'll turn this on instead so I can see the points. Let's just get the particles out. A couple of really quick setup things, so I will turn off gravity because I don't want them just dropping out of the world. That's pretty much all I think I want right now for these guys. Yep. Go to source particles. All that's good, all that's good. We'll be dealing with that in just a minute. Just to see our particles better, I'm going to put down a point scope. This. Which of course now that doesn't like, so we'll just switch that over. It's the quickest way to deal with it. It's fine. I'll turn that to sphere. I'll leave that as it is. And I'm just going to set them to be red right now. Let's have a look at these. There we go. Now what these guys are doing is they are, according to their instructions for life, they are moving along the normal that they've picked up from what's coming in at a rate of 1 unit per second. At least I think it's 1 unit per second. Somebody please correct me if I'm wrong. So they're just moving along the normal until they die, until they run out of life. The reason they stop is because there's an age limit of 2. So let's change that. Let's make the first thing we change. And we're going to be playing with a lot of the 2.3 stuff today because it's fun. So I'm going to put down a fractal noise field. I'm going to use this fractal noise field to control the lifespan of these particles. That's the first thing I'm going to do. And if I just went ahead and plugged this straight into the age limit, that's cool, that'd work. I've now got age limit in a spatial area, so depending on where the particle is in the field will depend on what its age limit is. When it's born, anyway. And so I can change the field around. But I think you can probably see that these are all very, very small, or more importantly, not there. And that's because fractal noise generates a number between minus 0.5 and 0.5. So of course anything with a negative age is just dead straight away, like these guys. So let's just do a bit of fixing up on that real quick. And what I'm going to do is I'm going to add, the real easy way to do this is I'm going to add 0.5 to it. And because these are fields, what I need to do is add a scalar field in there. So let's make a scalar field. How do I know it's a scalar field? Well, I hover over that and I look at what comes up. And it says core field, scalar field. And so that means if I plugged a vector field into that, it wouldn't be happy at all. So what I'm doing is I'm adding 0.5 to all of the field, which is being generated at minus 0.5 to 0.5, which shifts everything around to 0 to 1. And now we have particles coming out of every point that we scattered. I know it doesn't look like it for some of them, but if you zoom in real close, you can see them. So that's the next thing I need to work on, is I need that lifespan to be just a little bit longer. So what I'm going to do there is I'm just going to take this 0 to 1 I've generated, and I'm going to misspell multiply terribly. I'm going to multiply them with another scalar field, except this scalar field is going to be the maximum length of the life. So I'm going to say 5, and we'll just plug that straight into the age limit, like this. And now you can see that some of them are living quite a long time, and some of them are dying fairly quickly. And if I know it's this is not going to give you some instant feedback. You sort of have to trust the system here. What you can do is if you change the magnitude, change the frequencies, you can make that frequency quite high. So depending where things are in the field, things change. I can change the max number by just changing this scalar value here, the scalar field, down to 3, so they all die a little bit sooner. You get the idea. So I've just got particles coming out of my points that I scattered, which is good. That's what I wanted. So these guys, we'll probably come back to these guys a bit later. And now I'm going to do something with that tangent. And what I'm going to do, there's a couple of ways I could do this, but what I thought might be the best way is get geoproperty here. And I want the point tangent. Like this. And that point tangent is an array math float 3. And I'm going to do something just a little bit sort of like your friendly neighborhood effects department. I'm going to take these points coming out and I'm going to set a geoproperty on them. Set geoproperty on these points. So I'm making a new property, but the property that I'm making is point velocity, which is a math float 3. Helps if I plug the right thing in. Let's try that again. We'll take the normal speed off. And now, let's take that down a bit. So you can see them. You see that they're moving along the strand because I've taken the tangents and I've turned them into the velocity setting for the particles. This is exaggerating them just a little bit. Okay, so what's happening here is it's turning the tangents into a velocity for me, which I'm just plugging in. And if we have a look here, I've got my speed and my normal speed set to 0. So now the particles are emitting along the tangents of the strand. If I start increasing my normal speed, you can see that the spread is starting to come in, and they're also starting to bend away a little bit. So what this is doing, if you just watch here, you can see them bend away and bend towards. This is essentially adding the velocity and the velocity along the tangent and the velocity along the normal. So I'm able to get a blend of the two, which is great. So basically all I need to do is, if I want to have the start of some nice animation, or sort of a spray hose here, all I really need to do is set up a sine node and a time node. Now we're going to need the time node for stuff later on, so let's just make a master time node while we're here. So I'm going to take the frame out to a multiply, create a value node there, and I'm going to turn that into, oh I don't know, 1/3, 0.33. Let's feed that into the sine, and what the sine's going to put out is basically a number between minus 0.5 and 1 again, or minus 1 and 1. I'm not entirely sure. Let's find out. So you remember if we take the normal speed here, and that allowed us to bend off the tangents a little bit, so at 0 it's going to be along the tangent. At minus 0.5 they're going to start pointing towards the strand, minus 1, minus 2, they're going to start pointing towards the strand, and at 2 they're going to point away, because I'm blending the normal with the velocity I'm inheriting from the tangent, which is cool. So what I'm planning to do now is just stick this sine into the normal speed and see what happens. Now we're getting nice wavies. It's probably a little bit regular, but it's a nice sort of foreshadowing of what we're going to do. But what I'm trying to show here is that just by using two attributes we got off the scatter, the tangent and the normal, I'm able to have fairly good control of my emission direction. So I can have it come along the strand, or I could have it come away from the strand, or I have it anywhere in between, which is cool. But let's start doing some other stuff. So right now they're just boring old cones going out, dying at a certain age. That's a nice random age. So I'm going to have a scalar field again. I'm going to turn my time into a scalar field. I'm going to put down, well, this time I'm going to do a fractal turbulence field. Like this. And the time goes into the time slot. So that just means that this fractal turbulence field will evolve over time. And what I'm going to do here is I'm going to start by plugging in an influencer. So an influence, not plugging in an influencer. Don't know, you needed to recharge those. Maybe. So I'm going to do a modifier influence. What a modifier influence does is it allows you to modify either another influence or an actual property on your particle system, which is great because I want to modify a property on my particle system. I want to modify my point velocity, like this. And you see how everything's just stopped. Because right now I am replacing my point velocity is to replace with a value between 0, well, with this value, which is 0, at a rate of 1. Let's plug in this turbulence field and see what happens. What I need to plug that into is the value. We'll just restart the simulation. You can see here that after a little while, we start getting some turbulent motion. Which is great, that's what we want. Now, of course, because we've got a field, we can start playing with things like the magnitude to get more movement or less movement. Can make it more complex movement or less complex movement. And this is evolving over time, so that's why if I just took this out, restart the simulation, they're bending, but they're always bending the same way at the same place in the field. If I plug in the time, then the field itself is changing, and you get a much nicer look. So we're getting there. This is a fairly good way along the path to what we were showing in the introduction. Now, what it does need to start with is it needs quite a few more particles to. Well, it needs more points to scatter from. So that's what 300 looks like. That's looking pretty cool. Let's go to 3000 and see what's going on. So now we're just starting to get just a bit messy in particle cloud. So I'm actually going to take that back to about 500 because I want to keep some of that structure that the field has given me. But instead of pushing these points up, these are just the points the particles are being sourced from. What I'm going to do is change the particle rate as well. So we're getting quite a lot more particles being born. And now we're starting to get some decent complexity, which is great. That's kind of what I want there. You're getting some nice complexity. What I really want to do is I want to move them all as if they're in a wind. So let's get a wind modifier going on. This is looking pretty good right now. I'm pretty happy with that. I've still got all of my initial state controls here, so I can still have more spread. I can have less normal speed and a little bit more velocity, and that way it's going to go more along. You can see there, it's going along the strand before the field picks it up and starts messing with it. And that modifier influence, I can change how quickly the field affects it. So at 1, they get a little way, and then the field starts affecting it. If I say take that to 0.1, they're going to go quite a long way before. In fact, most of them will die before the field really takes hold. You can see it there and there. But I'm sort of happy with like 1.1-ish. It's not losing too much structure, but it's starting to break them up very, very quickly, which is quite I'm quite enjoying the way that looks. It's good. So we're almost there. I need to put down a wind influence. And this is where I'm going to take a look at my axes here, and I'm going to go, you know, this is all kind of, that's where the strand starts and that's where it ends. It's kind of going in the negative x. So I think maybe the wind should also be going in the negative x. And we'll plug that into our influence as well. So now not only are they moving along the strand as they're born and being picked up by the field, then the wind is now blowing them that way as well. It's not quite what we had in the introduction, but there's a reason for that. The introduction, basically this was a bit stronger, so we've got a 15 here. So it's going to really start pushing them around. See? It's a bit more like it. The wind was about right, but the big thing was that the strand was animated. So I'm just going to real quickly turn these off, so we're not having to cope with them. What I'm going to do is I'm just going to jump into my dummy strand. I'm going to animate this strand. And the way I'm going to do it is exactly the same way I did the particle turbulence. I'm going to plug a time node into the field, because this field is controlling. It's controlling, is it? Yes, it is. See, it's controlling this strand here. So if I was to just jump in here and change the seed, you can see it changes. But if I plug time into this field rather than changing the seed will jump like it just did. But if I plug time in here, so let's do that. Let's quickly lay down another time node and a scalar field. And why not a multiplier? Because we want to be able to control the speed of it. And you know, this is just a dummy strand I've made. You can make your own strands and do this with quite happily. Grab that, grab that. 0.2 is quite a nice number. Plug that into the scalar field. We'll plug this into the time. So you can just see that the field is just changing, maybe a little bit too fast, like this. We can go in here, of course, and we can start making the frequency a bit more complicated if we want to, like that. Change the frequency ratio, or the ratio and the frequency ratio. You know, whatever suits us. This is just, like I said, it's a dummy strand. It's doing dummy things, and it's floating around on the field. But what the time does is it allows us to make the field move smoothly, which is important. I mean, you can speed it up. That's what that's doing. And you know, you might want to sort of add something into the frequency to get it to change, or the ratio to get it to change. But for now, this is fine. I just wanted to show you, essentially, the strand is now moving. It's quietly moving. So that means as soon as I stick this back into the particle output, and let's go back here. You can see what's happening now. So that's a bit big and it's a bit fast to get what we had going in the introduction. Let's just change that to make it quite slow and subtle. That's more like it. So you can see each particle, when it's emitting, is still trying to follow all of the rules we set up. So I want you to go along your normal this much, I want you to go along the tangent this much, etc, etc, etc. This is breaking up a little bit too much now, so perhaps what I might want to do is go back to the field that controls the turbulence, and this is possibly a bit big now. I'll take that down to 8. Trying to keep a little bit more of the structure. So there you go, that's pretty much, if not the same as the intro, pretty close. And it shows you exactly what you can do with scatter around a strand. Because because Bifrost is procedural and everything is connected, this all started with literally 2 points. A point at the end of the strand, a point at the beginning of the strand. I then resampled that strand to give it some more points. I put a field on it, which I later animated, which is what's moving it now. And then I put it into the scatter around strand node and scattered 500 points with this curve. And you can see this curve being reflected here, and that it's still very quite tight here, and it gets fatter there. And that's because here I set it up. If I was to take this away, you can see it's still responding, and I'm playing it. It's not quite real time, but that's alright. If we undo that, there we go. And so now we've got our nose again. I can, quite happily make adjustments to that, so it's a bit fatter at that end, or the bulge is a bit further down the middle. These are all scatter settings, and they can all still be played with while you're using them to do something else to get the look you like. Very fast, very reactive, much fun. Alright, so that's pretty much it for scatter around strand. It's really quite simple. It's leveraging the power of the scatter on point node to give us what we need. Give it a bit more radius just to take a look at it as we go. So those are all starting a bit further away from the strand now. So yeah, I hope that's demonstrated it well, and you've all got your head around it, and feel free to pull it apart and play with it, and I'll let you go and see you on the next one. Cheers.